Welcome back. In this video I'll be telling you guys about quantified selves once again. This time it's a little bit more on the lighter side. We're not going to be talking about steps, but we're going to be talking about the Pokemon I caught playing Pokemon Go, which recently came out when I made this video. And I'm going to be looking at the Pokemon I caught hourly between the dates of 7/9 and 7/15, or July 9th and July 15th of 2016. And this just goes to show that quantified self doesn't really have to be about anything health related. It can be about anything you want it to be, anything you want to analyze or find trends in within your daily life. So a little bit about the difficulties doing this analysis, or this looking at the trends, was the fact that the Pokemon Go app doesn't provide a convenient way to export my data so that I can look at it in MATLAB. So I had to hand catalog the Pokemon I caught hourly, and then I put it into an Excel file. And I can go ahead and show you that Excel file to show you guys a bit about how it looks like. And once again, if you watched my previous video, you can see that there's a start time, there's a finish time, and there's the Pokemon caught per hour. And when you look at the start and finish, they look very similar to my last video because I formatted it this way just to make it simple on myself when I looked at the data in MATLAB. So we can go back over to the MATLAB code, and in the MATLAB code, the first step I always follow is just clearing everything, closing everything, and making sure my command window doesn't have anything in it. And if we evaluate that, you can see that the workspace is clear. So we can get started here. The first step, before we read the data, before we analyze the data, we want to go ahead and get the data into MATLAB. So I'm just going to get all the CSV files within my current workspace and my current working directory. And there's only one, so we get it in. It's called Pokemon.csv. After doing this, we want to get the data from our file into MATLAB so we can analyze it. So right now it's in a file structure, and since our file's variable only has one value in it, we can go ahead and get the name of that and then read a table from it. And what this does is what I showed you earlier of the Pokemon Go data. You can go ahead and see that there's 3 columns with data values in it, and when we run this and we look at our day data, we see that there's 3 columns with data in it. And we also get nans right here. That's probably because I was doing some things in the Excel file, but these are irrelevant to our analysis because we're not using them. So you can ignore these. But you can see that it labels the columns by what they were labeled in Excel. The start has the start times, the finish has the finish times, and they span an hourly interval, and the Pokemon are equal to the Pokemon I caught over that hour, which I cataloged. So after that, we want to make the start times into date time variables, and this will help us in our analysis because it'll ease the process of finding which weekday each data point occurred. And we can go ahead and look at that variable. It's called dates, and as you can see, it kind of looks the same as it did in our day data for the starts, because that's what I took it out of, but it just made it into a date time variable. Now, using that date time variable, I called it dates right here, we can find the weekdays that the date time occurred, where the WDN is the weekday number and the WKDY right here is the name of the weekday. And this will be helpful because in my analysis, what I'm trying to do here is go ahead and look at the differences over a week-long period of the Pokemon I caught. Specifically, I want to look at the differences between the weekdays and the weekends. So the difference between Monday through Friday versus the Saturday and Sunday, where I have more time, obviously, on the Saturdays and Sundays to have fun. So that's why I wanted to look at if there were any differences. But we can go ahead and go look at the weekday number. So the first date I put in, if you remember, was July 9th, and that corresponds to a weekday number of 7. So what does that really mean in MATLAB? Well, we can go to the WKDY, and we can see that it means Saturday. the first value means Saturday. So 7 means Saturday, then obviously the number 1 would correspond to Sunday, and then 2 through 6 would correspond to for Monday through Friday. So after we've gone ahead and done that, once again I left this value right here, this DVS value, and what that DVS value really helps us do is, it makes a vector out of our dates. And this would be particularly useful if we're trying to look at specific data within each day. So say we were only looking to look at the hours of noon till perhaps 5 o'clock. Well, you have noon right here, then you have 1, 2, 3, 4, 5, and if we were looking at only this data right here, the date vec function, where we can go ahead and put our variable, our date time variable, into a vector, it would just be easier for us to find the times and find the indices of the times where we're looking at. Say we're only looking at July 9th between noon and 5, as I stated. You can go ahead and find that it's 13 through 18, and then look at your Pokemon caught data, and you can look at the rows only 13 through 18 to see what's going on. So that's why the date vec function can be helpful in some applications. But before I go ahead and make those plots, I want to say that I took out the Pokemon data from my day data table because I just wanted to make it simpler for my plotting. So if I go ahead and run this for you, you can see that I get just one column out of doubles, and here we go. Here we have all the Pokemon I caught over that week-long period at hourly intervals. So just as I did for the last video where I was recording my steps and looking at my steps, I first ran my weekdays, so Monday through Friday, and my first run through I found all the places where my variable WDN, where my number of the week was equal to 2, which would be the day of Monday, as I explained earlier. And by doing this, I found all the indices where Monday occurs, and then I plotted only the indices where Monday occurs. And obviously, if we go ahead and we look at our day data, and you see this is Saturday, right? So this would be Sunday, and this would be Monday. So you'd go from midnight to the hour of the 23rd hour, or 11 o'clock. And that's what I did. I plotted from 0 to 23, and I plotted only the Monday, and I plotted in blue. And this process repeats itself over and over and plots all the weekdays. And the reason each day doesn't overwrite the previous day is because I have this hold on function, so they just plot one on top of each other. So if I go ahead and run this, and I can try to show you guys the graph right here, and you guys can see the graph right here, and in the graph you can see a lot of randomness or spiking, and we'll make more sense of this once we get all the data up. So let's go back to the MATLAB, and once I've done the weekdays, now I only have to do the weekends. And as I stated, the weekends would only be days 1 and day 7. Day 1 corresponding to Sunday, and day 7 corresponding to Saturday. And it's the same process as I did for the weekdays. It's just running the weekends and going ahead and plotting it, but this time I plotted it in red. So there we go. And before I go ahead and show you the data, let me just show you guys this. This is just a little bit about some of the plotting specifics. I just limited where my X values were, and labeled my axes and put a title on. But I also put a legend in, and some of you guys may be curious as to how to make a legend where your first 5 terms that you plotted were blue and the second 2 terms you plotted were red. And if you just made a normal legend where you just said weekday and weekend, well, they'd both appear as blue. So what you want to do is have your plot represented by a variable name. It's an object, obviously, and then go ahead and have one for the weekdays and have one for the weekends. So the last run through here the run through of Friday, you have H1 representing the line that is Friday, and H2 represents the line here that is the number of 7, which is Saturday. So then when I go ahead and make my legend, I'll just say only for H1, which is Friday, and only for H2, which is Saturday. Just call them weekday and weekend. And because of the fact that our values for all the weekdays were blue, that makes sense, and for values of all the weekends, Saturday and Sunday, were red, that also makes sense. So now I can finally go ahead and show you guys the plot and what it looks like. And you know, when we're looking at plots, we always want to gain something out of our plots, and you can see that there's clearly spikes in my data in the weekends that are much larger than my weekdays. And you know, the sense I make out of this is the fact that during this specific week, I ended up going to a new place. I ended up going to the New York area for a wedding, and that brought new Pokemon, new opportunities to do fun things that I wouldn't have been able to do on Drexel campus. And as a result, you can see that, you know, my number of Pokemon caught per hour has vastly increased in comparison to the weekdays. And that's what I get out of this data. And hopefully, whatever you use your quantified self to do, hopefully you can figure out what you're doing in your daily life, and it'll help you just monitor trends that are going on for yourself. Thank you once again, and best of luck.